Okay, sorry I'm a little late. Today we're going to start sort of our last topic, thank goodness, because I know we've covered a lot of territory in this class. Believe me, we could, if we had 2 semesters on this topic, we could fill them up with interesting stuff. Our last topic is AJAX. And we have already had AJAX. An AJAX example, although we probably didn't call it that way when we described it. Let me describe to you exactly what AJAX is. If, for example, you go to Google and you begin typing in the search bar. So I click on there, gives me a list of the top so many stories or items that people are searching for. As I start to type stuff in, sort of the IntelliSense works and starts displaying things that start with that letter. And the more I type, the more it will narrow it down. So if I type in HTML, I get HTML, HTML color codes, editor, table, HTML5, color picker, validator, and so on. If I type in AJAX, AJAX, I get apparently a soccer team, AJAX cleaning. And finally down here, I get AJAX and JavaScript. If we think about this, this doesn't really fit into the model of client and server that we've seen so far in this course. What I mean is this. The sort of traditional or standard model, non-AJAX model of communication between client and server works like this. We have a client. Typically, someone running a web browser on some device. It's connected to the internet. And it's communicating with a web server out there somewhere. The client makes a request. That request can include, well, it will include a URL at the absolute minimum. So I type in that I want to go to www.google.com or www.espn.com or something like that. All right. Now I might give some additional information. For example, if I go to Google and do a search, not only do I say I want the search results page, I give values from a form that says what specifically I want to search. All right. Or if I log into Canvas, in addition to asking for the Canvas homepage, I might supply my login credentials along with that so that it can verify that I'm a legal user and pull up the credentials specific to me. That request makes it through the internet somehow, gets to a web server. The web server does its thing. All right. In the case of a static page, it just retrieves the static page from where it's saved. In the case of a server-side script, it retrieves the script and processes the script, executes the instructions in the script, and so on. It might interact with a database, and it produces back an entire web page. which consists of HTML, CSS, and JavaScript. Now, the key thing here is in this traditional model, a request to a web server equates to getting back a complete web page from the web server. All right? Now, stuff that happens JavaScript is stuff that happens completely on the client side, because along with the HTML and CSS, the client receives back some JavaScript, which allows the client to have some interaction with the web page, such as the user puts their mouse on something and something appears. All right? Now, if we look at this Google search, let's see what's happening here. I start typing in cascading style sheets. Notice that it's giving me a list of stuff that starts with those letters, including C gives me the Cleveland Browns and the Cleveland Guardians. CA gives us the Cleveland Cavaliers. So it's doing it intelligently. It's not just giving us this fixed list, it's doing it dynamically. That is, it's looking at aspects of our request, including what our location is, our location being determined by what our IP address does, and it's returning a list just for us. And if I was logged in to Google, it would probably do an even better job fine-tuning these results to match my previous search histories. But as I continue to type in cascading style sheets, I get to it. So one part of this appears to be JavaScript because there's interactivity. Just like there's interactivity if I go to, say, ESPN's page. And as I put my mouse on different items, different stuff appears. That's interactivity. What happens in this case is what got delivered to the browser was the entire web page, including some things that are invisible. And then there's JavaScript to make those things visible as I put my mouse over them. So there's interactivity in this case too. As I type something in, I get a list, and that list changes. So that would suggest that there's some client-side scripting going on here, because this interactivity happens without refreshing the page, without getting a brand new page. All right, just like my interactivity here, as I put my mouse over things, I don't get a brand new page. I don't see the page refresh. I simply see that content appear. Same thing over here. As I'm typing in something in here, I get interactivity. The whole page doesn't reload. The page just changes the way it looks to display a list of topics that I might be interested in. So that would suggest that client-side scripting is doing something here. And yet, as we type something in, the fact that it is gearing my search results to me, Cleveland Browns, Cleveland Guardians, based on my location, tabs, Case Western Reserve, which is in the Cleveland area, Cascade Park, which is in Elyria, and so on. That leads me to believe that there's some of this action going on too. Some of this stuff over here, where the script is taking my request and querying some sort of database that it has of the websites and coming up with a list of suggestions geared just for me. All right. That couldn't take place on the client side because that appears to involve database interactivity. So there's some heavy lifting going on here, the kind of thing that only a web server can provide. So in analyzing this using the traditional model is very confusing. Is it client-side scripting? Is it server-side scripting? And the answer is it's both, but it's a different model than this. It's not the traditional model of a request to the server returning back a complete web page. It's a different kind of request. It's an XML HTTP request, as opposed to a standard request or an HTTP request. And the difference is this request is made through JavaScript. It's not made by clicking on a link or typing in the address bar or clicking a submit button. This kind of request is made through JavaScript based on JavaScript events. So for example, here as we type in, notice as soon as I hit the key, you can't really see my hands, but as I hit the key, the new search terms appear. So that is an on-key down event, if we were going to look at this. So the on-key down event triggers this request to the server. But it's a different kind of request. HTML XTTP requests to the web server don't return a whole page. They return a chunk of data. To get sent back to the client. And JavaScript then takes that data and formats it and updates the page. So if we're going to just draw, I'm just going to draw AJAX requests here on the next drawing that I do. AJAX requests typically happen after the initial page load. So we have a page that we're viewing in the client. The user does something, so an event occurs. An XML HTTP request is made through the internet to a web server. That server processes it just like it would process any other request. Typically by loading up a server-side script, maybe interacting with the database. And it returns something back to the client, but it doesn't return an entire page. It returns some data in some format. That data is taken by JavaScript then and integrated into the current page. So we can change the data on the page without getting a whole brand new page back from the server. So I mentioned we've already seen an example for this. So let me go to Canvas and show you the example. Show me what we've done in AJAX already this semester. We're going to this page, and we got the weather query, real-time weather app. And let me Download the code. And let's look at it. Well, I said that this is AJAX. Let's see if we can understand why I came to that conclusion. I open up the web page. It wants to know my location. I'm going to allow it. And it shows me that the temperature is 2 degrees Celsius and broken clouds in Sheffield, USA. Right? It displays the page that looks like this. When I first go to the page, this is what I get. JavaScript then wants to know my location because it wants to make an AJAX call to the web server that handles the weather and get back weather data. So when I say allow, that AJAX request is made to the weather web server to get back a piece of data and update this page. So we're not going to redraw this page completely. We're going to update the page that initially loaded. In this case, there is no user action other than loading the page. So it's not like if we start typing something in or if we click a link to say, go ahead and retrieve data or something like that. The user action is actually loading the page. So the initial page gets loaded with blanks in it. If we allow the location, that page gets updated with data from the web server. And there we go. So let's look at the code and try to figure out what does this. This actually uses jQuery to accomplish that. We've talked about jQuery earlier, and we've said that jQuery is a library of functions built on top of JavaScript, and it makes some things easier than it would be if we did it just in JavaScript. All right, actually, we have to look at JS for this. All right, so we looked at this before. I'm not going to focus on all the details of this. I want to focus on where it makes the AJAX request and how it handles it. So coming over here, it looks to see if it can get the current position. If so, then it calls set position. Otherwise, it calls show error. So if I give it permission, it's going to call set position. And set position gets the latitude and longitude and calls get weather. Here is where the fun starts. The server script that I'm calling is this. API openweathermap.org, and that request is formatted with the necessary information, namely the latitude, the longitude, and the app ID key, which is needed to do a query. I then call fetch. Fetch is making an AJAX request. It's making a HTML or an XML HTTP request. Now, the word AJAX I've been using the word AJAX without telling you what it means. Well, I've told what it means. I haven't said why it's called AJAX. Let's put it that way. AJAX stands for asynchronous. JavaScript and XML. Now, let's sort of break down this. JavaScript, well, we've sort of seen the role of AJAX, of JavaScript and AJAX. The role of JavaScript and AJAX is to make the request and format the response. So that's the JavaScript part of it. XML relates to one of the ways that data can be sent from the server back to the client. It's not the only way, but it's one of the ways. When it was first used, it was probably used more often now. Now, oftentimes, the data comes back as JSON objects. All right, which it does in this example. But the key word I want to talk about is asynchronous. Asynchronous means that when we make this request using AJAX, the client doesn't know how long it's going to take the server to respond to it. So the client makes the request. It can't immediately start formatting the data. It has to wait until the server is done and has sent the data before it can start formatting it. So it doesn't have to happen simultaneously. This doesn't have to happen bang, bang, bang. The request can be made. Server can do its thing. Maybe if there's a slow internet connection or the server is particularly busy, it might take more time. Maybe on other days, it might take less time. But at some point, this data is going to come back. And at that point, when the data is returned, the JavaScript can do its thing and format the data and update the page. Well, that's what then means in the fetch. All right. After we get the data back, this is what happens. We grab from the response the JSON data. Then we do this. And then we do this. So there's a stream of things that we do that initially gets triggered when the data comes back, when we've gotten a response from the server. When the server comes back with a response, that sets the ball rolling. So we do this. We grab the JSON data, not XML in this case, but JSON. Then we do this. We don't do this until this is finished. And we don't do this until this is finished. But after we get back the JSON data, then we can grab the different values from the JSON data, and then we can display the weather. So this is asynchronous. In other words, as soon as we make this request, we don't immediately start processing it. We wait until we get a response back from the server. That's what this means. Then we wait to do this until this gets done. We wait to do this until this gets done. Make the request, server does its thing. When the data comes back, then we do the next step, the next step, the next step. So it is asynchronous. We're not immediately going to start trying to format the data until we know we've gotten the data back from the server. And that's what makes this AJAX. If we were looking about this, jQuery fetch data from API. There's instructions about how to get the data. This is a get. I don't want the get, I want the fetch. It's later on down the page. Anyhow, there's more information here that describes it in more detail. Okay, now that's how we did it in jQuery, and you can continue to do AJAX requests in jQuery, but I do want to show an example of how you could code it in just plain old pure vanilla JavaScript. Because I think it's essential to understand what exactly happens in an AJAX request to really look at the nuts and bolts level and see how it's done in JavaScript. Therefore, I've taken this example. One of the last things we worked on in class. And this is the heart rate calculator. I'm going to move my files into CINet pub wwroot. We can use AJAX calls to someone else's API. We can also use AJAX calls to our code that we have written. All right, I have this AJAX calculator done two ways. I have the AJAX calculator done using pure vanilla JavaScript and using jQuery. This is a calculator that worked before. If you remember, we typed in our value, we clicked calculate, and we went to another page to show the results. Now, I did show an example of a postback where it went and reloaded the same page, but these examples, the AJAX ones, happen without reloading the page at all. So if I type in that I'm 20 and my heart rate is 10 beats in 6 seconds, calculate, that gets updated without reloading the page at all. This one does the same thing, it just uses jQuery instead of just plain JavaScript. So let's look at check range AJAX jQuery. It'll look similar to what we've seen before. That's why I wanted to do this one first. Actually, this uses a somewhat different method. Let's save this for later. I changed my mind. This doesn't look like what we did before. So many ways to do things. I can understand why you might be confused about stuff. Why do we teach so many different ways? Well, because, you know, each one possibly has its advantages or disadvantages. Plus, you might be working on code that someone else did and might have done some things different ways. Like, so for example, If you were working on a project to use AJAX and they did not use jQuery, I don't want you to be totally confused. All right, so let's look at this version. All right, notice first of all that this is not a submit button. So we're not submitting this form to the server. It's a plain old button. And we're calling process form when the button is clicked. What does process form do? It validates the form, make sure that the data is valid. If it's valid, it makes the AJAX call. The very first thing that happens, though, when the page loads, notice how this is outside of the function. Therefore, this gets executed as soon as the page loads. Is we create this request object called HTTP. This request object is the pipeline between the client and the server. It's what we're going to use to get the results and make the request. I should flip those around, to make the request and then get the results. We do that this way. This little snippet of code is just in there for old browser compatibility with Internet Explorer. Well, there probably are still some people who use Internet Explorer, so we would keep that in. The bottom line is what this does is that when this function is done, we have in this variable a request object. So when we're ready to make the AJAX request, we define a URL. We grab the value for age. We grab the value for beats. We concatenate them to the URL. And then we open the URL. And then we say on state ready change, call hand response, and then we actually make the request. So what we're going to do is we're going to call check range ajax.php, and we're going to pass on the query string a value for the age and a value for the beats. I'm going to put in a write to the log I'll just do an alert. I'm going to display the URL so that you can see what it is. So I type in my age is 30, beats per 6 second 11. I click calculate. That's the URL that's called check range Ajax PHP. Test age equals 30, test beats equals 11. It's a good idea to know the exact URL that got called, because if it doesn't work, you want to see maybe you didn't format that URL correctly. Maybe you didn't format the query string correctly, where there's a comma after the URL name and there's a field equals value, field equals value. You can test out that URL simply by concatenating onto the end of localhost. I thought I copied it. And it shows me the response I get from the server. Notice the response I get is not the entire web page. It's just a piece of data. That piece of data is not XML, nor is it JSON. It's just plain old text. On-ready status change, on-ready state change will get called every time the status of the request changes. And there's a whole list of statuses that it goes through, that the request was sent, that the server's waiting to act upon it, that the server has started to respond. We're only interested in the ready state of 4 for the request. That means that the request has been completed. And if the request has been completed, we take the response text where the response lives, and we just pop it in the inner HTML of response. So server-side script that we call is a URL. This is called a callback function. This is a function that gets called every time the status of that request changes. And we're interested if the value is equal to 4, because that indicates that the request has been completed. All right, we're actually a little ahead of the game, so I'm not going to press on too much farther. I have a little bit more about AJAX. There will be one AJAX assignment, probably just one AJAX assignment. I have to look at the schedule, and we'll cover more examples in AJAX next time. Are there any questions at this point? Wait for a second. Are there any questions? Will we have other, that kind of faded off the screen fast. Will we have any other assignments after AJAX? Only 5 or 6 more. I'm just kidding. No, there probably will be only one more assignment. All right. And it will be with AJAX. You guys have done a lot this semester. Again, if it's any consolation at all, there's a lot more I wish I did have time to cover that we just were not able to get to because of time, and we couldn't possibly squeeze into one semester. So there will be one AJAX assignment, and I still have to decide what exactly that's going to be. All right, if there are no further questions, that's all I had for today. Happy programming. We'll see you next week.